Hey there, this is another video on the os8088 operating system that I'm building for really old computers like the IBM XT. Um, and in this video, I want to go ahead and show you how I'm building a sound system for the operating system. I'm going to start with the speaker, but eventually I will support Adlib and Sound Blaster cards. So that's something that is definitely something I want to do. And but before I get started, I want to mention that I did upgrade the microphone. Hopefully, this is coming out much clearer than the previous ones. This is a actual standalone microphone instead of the one that is built into the MacBook Air that I'm using to record these. So just wanted to call that out and would love your feedback in the comments if the sound is coming out better. All right, so here's what we're gonna be doing. I want to be able to create a sound layer, a sound interface in the operating system itself that can then use different outputs to support sound. So let's do that. I want to create a sound layer in the operating system that can have multiple inputs and outputs. I want this layer to be flexible so that I can play sound on the PC speaker, maybe even sound waves, including sound waves, not maybe, including sound waves, and also eventually attach other sound cards as inputs, outputs, like the Adlib and Sound Blaster series of cards. So I'm going to leave it open-ended like this. Fill in the gaps in the plan. All right, so one thing that I do want to do is I want to have this ultra coded. I want to ultra code. All right, so I'm going to do this. I'm going to kick this off, and then we'll see how far it gets. Hopefully, we'll have a sound layer built into the operating system in about 30 minutes. Let's see. I'm giving it 30 minutes. I think it might take less than that. It might take more than that. But we'll start here. And I'll, with the magic of editing, I'll pause my recording here and then we'll continue in a moment. All right, let's do a quick check-in at the 26-minute mark. And it says it has 10 out of 14 agents done. And it's using a workflow. Now, a workflow is something that Claude Code uses to organize its agents to do different tasks. So, for example, it ran a phase to understand the timing. So, if we go here, we can see that it's going through the process of understanding how the actual app is wired together. And let me see if I press enter to expand. OS88 is a Macintosh, blah, blah, blah. It gave the context of what it is, what the computer is, operating system is like. And the floor machine is an 8088 4.77 megahertz, preemptive round robin multitasking off the pit. So it gave it the context of what the application is. So you are mapping the timing and concurrency terrain of the OS8088 kernel. So this is at the understanding phase. Memory API. This one is to see what is the task here. Let's go down here. You are mapping the memory API surface and extension terrain of OS88. So this one is looking at the memory API surface and extension. So how do we go ahead and extend the operating system? And the hardware, this one is doing what? If I go down here, So it gives a context and then it gives it the task. You are the sound hardware domain expert. Compile a precise implementation grade reference for driving these devices from real mode 8086 assembly on a 4.77 megahertz 8088 floor machine. So use your knowledge and web search, web fetch to verify anything you are unsure of. Port numbers, DSP combined bytes timing. PC speaker, square wave tones via P channel 2 mode 3 plus port 61. Blah, blah. Sequence sampled playback techniques and their true cost on a 4.77 megahertz pulse width modulation via channel 2. All right, 6 to 16 kilohertz driven by channel 0 interrupts versus cycle counted busy loops. Okay, realistic achievable sample rates and per sample ISR. And then Sound Blaster 1.0, 2.0 Pro, DSP reset handshake version. All right, all this other stuff. Tandy PC Junior. Ooh, interesting. I wonder what it's going to... Gesto abstraction is not painted into a corner. All right, so it's going beyond what I asked it to. That's good. So design, it went and designed a minimal core. So what does that look like? It gives the context, and then it's going to explain some facts. Reprograms the, okay, so it gives a, and then does predict. So it gives this context of how the machine works. And then does it have a task? It's a lot of context. Oh, there's 1,000 lines. All right, this is a lot. Minimal core. Oh boy. All right, so there's a lot of stuff going on here. You see why I like to give it let it figure out all the context itself. Okay, design routing graph. Which one is that one? That one took 5 minutes to do. I think, I don't know if these run in parallel. Let me see, this is a, it gives it all the facts, and then at the end it probably has a, the command, like the actual request. Judge, 3 judges. What does this do? Oh, I can't. I have to use J and K to go line by line. I can't, it's going to take forever for me to get to the point where the context turns into a request, because every single prompt seems to get all the context to be able to do its job reliably. Synthesize, verify. Okay, so it should be done right now. So it's about to be done, and it took, you know, about 31 minutes. Let's see here. So let me let it wrap up here, and then we'll continue the video as soon as I get a result, a summary. All right, so here's what happened. It took 41 minutes to create the plan. So all of that work was not actually doing any coding yet. It created a sound plan, and it looked at how to actually build this out. And it determined that there was an architecture that it wanted to follow here. It wanted to use a driver table with capability tiers. So tone, FM, PCM background, PCM exclusive, PCM input. And it really tried to make it as flexible as possible, I think. It also looked into what it means to do sampled sound on a PC speaker without touching the scheduler's timer. The 18.2 hertz BIOS chain is too restrictive. So what it's going to do is it's going to do PWM one shots on channel 2 and as a free running clock. And it's that should provide 8 kilohertz 7-bit audio, click to skip. I don't know what that means. And then a buffers and sound segment, the last free 64 kilobyte on a 256 kilobyte machine, which happens to sit entirely inside 8237 DMA page 3. making every Sound Blaster buffer page crossing safe by construction. Interesting. 5 new. So we'll probably have an 86 box configuration with a Sound Blaster 1, maybe, if that's available in there. It should be. And then try some cool stuff. So what I want to do now, each shippable and QMP testable alone, tone core, blah, blah, blah. All right. With a wave capture. Interesting. All right. All right, so what I'm going to do is like ultra code the sound plan MD implementation. Then ultra code a sound wave player, recorder and player. Also include as an app package. All right, so I want to do the sound plan implementation, then ultra code a sound wave recorder and player as an app package, then ultra code a piano, a colorful piano with waveform, with wave, no, not with wave, with a the ability with that plays tones and shows a musical note viewer on top of the piano that shows the notes as you play them, and then you can replay the notes. Include sample songs to play in the piano that the user can load. All right, so this is a lot of ultra code. So this is probably going to take a while. So let's let it run, and then hopefully by the time this is done, we'll have sound with a piano, a wave recorder and player, and all of that stuff. So let's go for it. And then we'll check back when it's done. All right, let's do a quick check-in. It's been almost 15 minutes, and I've done laundry, I've eaten lunch. That's the beauty of AI coding, and we're still impatient. 15 minutes is too long. Come on, to build an entire sound system, or sound subsystem. Let's just say that. All right, so what is going on? Let's take a look at the workflows. So there was a design 14 agents with 1.1 million tokens that took 31 minutes, and then this one right now, the implementation one that is running, that's the one that we looked at, right? Yes, that's the one that we looked at. And then now the one that is running, the tone core is there's a spec, so let's take a look at that one. This one is mandatory reading. You're working in this sound layer branch. The repo is os8088 on Mac, blah, blah, blah. And it gives it some non-negotiable rules, testing, get discipline. All right, so that's that. Then we got the tone core. What does this mean? It means okay, it gives it a bunch of context, and then again, oh, this is faster though. Let me see. So enter J, non-negotiable rules, and then we go testing, and then never push task. Implement P1 tone core. Implement sound plan phase 1 exactly as its phase bullet plus plan sections. Specify sound skeleton, driver table, and speaker row. All right, so it's gonna do a tone core. It's gonna review it and test it. It's already done that. The speaker PCM support, that is happening right now. And that one is also very short. It's just referencing that in original spec. It looks like it. Implement P2 speaker PCM phase 2. Never clamp and resync. So that one is going to be doing that. And it's going to be doing OPL2, Sound Blaster support, and then recording. All right, I'm curious what this is going to be like. So, all right, it looks like this is going to take hours. So let's see how long it's going to take. It's currently taking, let me see, escape to close. It's currently at 52 minutes, and it's only done with 2. So I'm assuming this is going to take a couple of hours at the very least, maybe 2 or 3 hours to wrap up. And what is my usage like? Okay, so I currently have 24% usage for Fable, which is the one that I'm using to build this out. So I think I'm good. I think I'm good with this. So let's let it run, and we'll check back a little bit later. All right, we've hit a little bit of a snag, unfortunately. So you can see here, the agents are failing, and that is because Claude is down. So if I go here to Claude status, you can see that there are issues right now. So the good thing is that it's been down for about 40 minutes, and this will continue retrying for a bit. I don't know if it's gonna ever give up, but hopefully it'll come back and start working again before this fails completely. I don't know how many retries it'll do. Like, so you see here, it's, you know, it's trying, but it's gonna have to restart some of these because the back end, the server on Claude side is down. So that's unfortunate. Hopefully, it'll actually be able to recover safely. All right, so it is done, and it took 6 hours to do this. So it is the next day, and here we are. I think 6 hours takes into account the time that it was down, I think, because I don't think it took 6 hours completely. But let me see, workflows. We can see that this took, sound apps took 2 hours to build. The sound layer, the one that had the downtime, was 4 hours. Okay, so that is quite a lot of time actually coding. So this took, the recorder took 24 minutes, 13 minutes, piano took. So, and in the integration, very interesting how long that took. But it was doing it while I slept, so that's good. Let's see here. Can complain for that, you know? It's a different way of writing software for sure. You just tell the computer what you want, and you wake up and you see if you got what you wanted. All right, so let me go ahead and open a new tab here, and you can see here everything is already checked in. So I am gonna go make XT. Let's see how it works with just the 256 kilobyte one, and we should be able to play the piano and using the speaker, I think. So we'll see how that works. All right, so here we are getting inside the operating system. All right, so let me see what's going on here. So nothing here, nothing here. Control panel. Oh, there's a sound. I didn't ask for this, but oh, nice. Test. Exclusive clips. Clips freeze GUI. Okay. Adlib, no. Okay, no Adlib detected. Let me see. That sounds like a ring. I hope you can hear that. I'm not sure if you can hear that or not, but yeah. Let me just make sure that the recording is capturing that. All right, so yeah, you were able to hear that. So I'm not sure if that's the way it's supposed to sound, but you know, all right, let's give the piano a shot. So I'm assuming disk B has the application. All right. Oh, and it gave it a little icon. And the recorder has a microphone. Nice. All right, though. So that piano is 2.6, 2.7 kilobytes. So it's our largest application yet. All right. Maybe that's because it has some sound notes. Oh, look at this. Got Twinkle Twinkle, Ode, and Mary had a little lamb. Little lamb. All right. So let's load Mary. Look at the notes. That's cool. And how do I replay? Replay. All right, that was cool, and it does freeze the um the UI. So clear me Mary had a little lamb, little lamb, lamb. Oops, I got it wrong. All right, so you can also use the keys like the keyboard. A S D F G H A K L. All right, so that's cool. So we have that. How about Twinkle Twinkle Little Star? All right. I know this is probably going to be very loud for you, so I apologize for that. But hey, we have sound now. And let's see the recorder. There is no way to record, but I see how it looks. Okay. Oh, I wonder if it has a demo. Play. Oh, that doesn't sound good at all. That's like I don't know what that's supposed to be. That's like some computer generated uh, junk. If an AI were to speak, maybe that's what it would sound like. There you go. Yeah, I don't think that was right. I think we'll come up with a better demo in another PR, but all right, that's cool. So we have sound. I don't know. I think one thing we could do, there is no Adlib detected, so maybe we could try Adlib support. Let's go ahead and I'm gonna make a release here. I'm gonna cut the video here since I think we made some good progress, and I'm gonna publish a release. And in the next video, I'm gonna see how well the Adlib supports works. I want to see if we can make record a waveform and play it back. I don't have high hopes with a 4.77 megahertz, so maybe our sound capable machine will be a little bit faster, like a 286. But in the spirit of trying to make I think a 4.77 megahertz machine should be able to play some basic waveforms, like an 8 kilohertz waveform. So let's give that a shot. All right, well, if you like this kind of stuff, just make sure you subscribe. I have some other projects that I will also be doing a series on, which are also very, very interesting. It's a way for you to write basic programs in the browser, and that one I think is going to be something that is going to be even more hands-on for everybody that is watching this. So yeah, let me know what you think in the comments, and I'll publish another video really soon. Thank you.